All right, we're going to take the derivative of g of theta here. G of theta can be rewritten to make this a little easier on us without the radicals and without this trig notation here that can cause issues with people when doing derivatives. I rewrite it so the power rule and the chain rule is really evident to see every single time. So I need to find g prime of theta. So g prime of theta requires the chain rule a couple times. But let's start with the outside part. It's something to the 1/2 power. So to take the derivative of that, that's 1/2 to the negative 1/2. And the inside comes down and stays the same. Alright, then I have to multiply times the derivative with respect to x of the original inside. A squared minus sine of theta squared. Now, whenever you see something that's a function of theta and you see another letter in there, that letter represents a constant. So you don't want to think of this, you know, don't go speeding through this and think, oh, a squared, that's 2a. Don't do that. It's actually the derivative of a constant, and that derivative of a constant is 0. Don't forget stuff like that. Go slow, take your time, and think. Stuff doesn't come natural to you until you've done it a long time. So I'm just going to rewrite the first part. And then I'm taking the derivative of this piece. So the derivative of a squared is 0, and I am going to put it in there just for the time being to keep it like a placeholder. And then this guy uses the chain rule 2 to take the derivative. So a derivative of the outside is 2 to the first power. And then the inside stays the same. And then the derivative of the inside is cosine theta. Hope I'm not going off the page there. I don't think I am. Now, if I simplify this just a little bit, I'm not going to do a whole lot. I'm just going to rewrite this. And then rewrite this a little bit. This is minus 2 sine theta, cosine theta. And again, I'll just continue simplifying. Those 2's will cancel with one another. This tells me that that part goes in the denominator. So this stays in the numerator, so minus sine theta, cosine theta. And then in the denominator, I get a squared minus sine squared theta to the 1/2. Notice that the negative here is now positive. And that's what simplifies it. A good rule of thumb, whenever you simplify stuff for mathematics, is making sure that there are no negative exponents left in your equation.